This is my channel. My name is Adamu. I shall be proving a formula of a capacitive reactance of a capacitor. As you can see on board, to show that Xc is equals to 1 all over 2 pi Fc, where this Xc here represents the capacitive reactance of the capacitor. Then this 2 pi is a constant, of course we know that, and F is frequency of the oscillation of the AC is passing through the capacitor. Then this C here is the capacitance of the capacitor. Now you can agree with me that Q, the quantity of charge in the capacitor, is related to the product of the capacitance of the capacitor and the potential difference between the paraplate of the capacitor. You have your Q is equals to CV. And on this, we also know that an alternating voltage is written as, if this is A equation, your V will be equals to V naught sine omega t. And if we put this in this, we will have our Q to be equals to C V naught sine omega t. And when we label this as your V, when we differentiate this with respect to t, you will have that your dq all over dt, which of course you know the time rate of quantity of charges is equals to current. So this one will be the same thing as current I, and is equals to you have this is a constant, you have your CV naught, and when you differentiate a sign, you have omega, this a constant come down here, you will have cos omega t. And looking at this, it's a very essential equation that we must label it as what? C. And you should also recall from Ohm's law, there is also a relationship between the voltage, current, and resistance. And looking at this one, this capacitive reactance is just like the opposition to the flow of AC that is being offered by the capacitor. So I can write confidently from Ohm's law that our V is equals to I x C. This, where this is potential difference, V is potential difference, I is the current that's flowing through it, and your XC subscript is the what? The opposition to the flow of AC by the capacitor. And if you do that well, you will see that if we make XC now the subject of the formula, you will have that your XC will be equals to V all over what? I. Where this XC is equals to V all over I. Remember, this is from Ohm's law. I said the product of current and resistance is always equals to the potential difference. That's what Ohm's law is talking about. Now, and when you bring all these important equations, now we have our V. Look at it up here. And we also have our I. Look at it here. So when we put in V and I in this equation, let me label it as D, we will have that our XC will be equals, now look at it. We have our V, which is equals to V naught sine omega t. We put in the place of the V. V naught sine omega t, all divided by the current, which is what? Now look at the current here. Look at it here. The differential value of this Q to respect to time gives you C V naught omega cos what? Omega theta. T. So you have this one to be substituted down here. You have C V naught omega cos omega t. Now look at it. This your V naught, strike out V naught. You are left with what? Your XC to be equals to your sine omega t all over C omega cos omega t. If you remember in trig ratio, the sine all over cos an angle is always equals to tan. What do I mean by that? If I have sine omega t all over cos omega t is equals to tan omega t. So when it is like that, you know this particular equation E, I can write it as my xc is equals to 1 all over omega c multiplied by sine omega t all over cos omega t. And this ratio here is equal to just what? Tan. So if you have to put it in, you have your xc is equals to 1 all over omega c is equals, multiplied by a tan omega t. Now, if you let the angle, remember this theta is the same thing as omega t. So when we let the theta now to be equals to 45, what am I trying to say here? That the angle of oscillation to be at what? 45 degrees, or equals to pi all over 4 rad. We have that if theta or omega t is equals to 45 degrees, which is the same thing as pi all over 4 rads, and we put it in this equation now, we will have that x c is equals to 1 all over omega c multiplied by tan 45 degrees. On your calculator, when you punch tan 45 degrees, you get 1. Tan 45 is 1. So if you now punch it, you now write but your tan 45 degrees is equals to what? 1. Putting it back here, you have xc is equals to 1 all over omega c multiplied by what? 1. And remember, even anything multiplied by 1 is just that thing. So we have this to be equals to 1 all over omega c. But you will know that this omega is related to this particular formula. We know that omega is the same thing as 2 pi f. 2 pi f. Now, if we put it in this formula, we will have that your xc now will be equals to 1 all over 2 pi lc. You can see that we have shown that the capacitive reactance of a capacitor is equal to the inverse of the product of 2 pi frequency and the capacitance of a capacitor. Thanks for watching this video.